Welcome everyone to the GSTEAM Academy course for mentors and to the module dedicated to gender gaps in STEM, from historical inequalities to present challenges. It's a bit mission impossible to cover such a complex and dense topic, but we'll give it a try. Starting with few considerations on the fact that the history of science can also be seen as a history of exclusion and hidden contributions. Several scholars like Mershon, Evelyn Fox-Keller, Sandra Harding, and many others, feminist epistemologists and feminist historian of science have shed light on the gendered boundaries of science. Historically, we can refer to institutional exclusion as universities and scientific academies were explicitly male only and or were structured around male citizenship and clerical professional pathways. Less visible but still present barriers were featuring universities and scientific academies, as in mathematics and science, for example. Access was depending on earlier access requisites like language skills, especially Latin historically, or geometry. Other gatekeeping mechanisms were at play in terms of funding, access to conferences, to professional titles, whereas entry points were controlled by closed networks. We might wonder to what point those entry points in science are still controlled by closed networks anyway. Furthermore, the epistemology of and the definition of reason were shaped around gendered ideas as a deep cultural script linked rationality, abstraction, and authority to masculinity. We could say actually to masculinity and whiteness as well. This link between abstraction, rationality, and masculinity was in particular strong for mathematics, often treated as the purest form of reason. So in spite of the fact that women were kept away from higher education, they gave a huge contribution to the advancement of scientific knowledge, a contribution which has been mostly erased by the history of science. Women were never or very seldom mentioned in textbooks, and this contributed to reinforcing a social imagery of science as a white and men's thing. The exclusion of women and other marginalized subjects for knowledge production led to not considering gender and other differences also from as key dimensions in shaping the content and the methods of scientific research, particularly whenever a research has has to do with human beings. So this led to not considering sex and gender when, for example, performing research on in clinical studies and medicine, just to make one of many possible examples, and therefore missing half of the population and failing half of the population for from an accurate description of symptoms and pharmaceutical impacts and effects. Here, we wanted to give credit to some scientists, some women scientists, few of them with minority backgrounds that normally are not acknowledged among the wall fame of science. Many of these women were often supporting, making the work of male scientists, sometimes their husbands, possible. And this is also why we want to consider another form of systematic invisibilization of women scientists that is known for being named as the Matilda effect. This phenomenon was named after suffragist Matilda Jocelyn Gage, who had earlier argued that women's inventive scientific work was routinely denied recognition or instead attributed to men. The Matilda effect as a term was coined by Margaret Rossiter, a historian of science at Cornell University in 1993. Where she described a systematic invisibilization phenomenon, insisting that the missing women were not just a demographic fact, but also a credit and memory problem. So the Matilda effect concept helps us see beyond individual injustice because it points to a systematic mechanism and the fact that authorship and credit, even in science, tend to follow hierarchy. The women mostly referenced as victims of the Matilda effect. The most famous ones were Rosalind Franklin, who is now recognized as a key contributor to the discovery of DNA structure, but at the time of such discovery, she was not credited. Francis Crick and James Watson received a Nobel Prize, although later on Watson also recognized the importance of her contribution a few years later. The other typical renowned example is Liz Meitner. A Nobel Prize in chemistry was given in 1944 to Otto Hahn for laying the theoretical foundation for nuclear fission. She was working with Hahn, and she was actually the main contributor and the one who even coined the term nuclear fission. but she was not recognized by the Nobel Prize Committee, partly due to her gender and partly due to her ethnic and religious identity, being a Jewish in Nazi Germany. So that is the historical component and background that is interesting and useful to start with and be aware of, to also take stock of present inequalities as far as gender and STEM education are concerned. So when we refer to present times, we often distinguish between horizontal gender segregation and vertical gender segregation, whereas horizontal gender segregation refers to gender patterns along the different scientific disciplines and sectors. And we can observe persisting gendered study choices. So looking at the recent data from Eurostat on the distribution of tertiary education students by broad fields and sex, we see how, well, women are still the majority of all tertiary education graduates. In 2023, they were 54.8% of the overall graduated students across the EU. And more than a fifth of all students in tertiary education were studying business, administration, or law. 22% of all students, and women accounted for a majority of the total number of students within this field of education. You can see it from the first bar in this in the chart displayed on the slide. The second most common field of education was engineering, manufacturing, and construction, accounting for 14.7% of all tertiary education students. In this field, almost 3/4, 72.3% of all students were male. The third largest field of study was health and welfare, counting for 14.4% of all tertiary education students. And here, women instead were the large majority, 72.4%. So the only other field of study to account for a double-digit share of tertiary education students was arts and humanities, where women also represented the relative majority, 65 something percent. So this is clearly showing a strong horizontal segregation by gender that reflects traditional stereotypes. Women all concentrated in what has to do with care, society, humanities, education, while STEM subjects, and in particular, what is striking is the 79.7% of men in information and communication technologies, also reflecting a gender stereotype in this sense. So if we go and take a closer look at STEM graduates, so in recent years, increasing attention has been paid to the representation of women in STEM education fields. As we said, there is an underrepresentation issue of women in STEM. And in 2021, at the EU level, as you can see here, in STEM fields, women accounted for slightly more than 30% of all STEM graduates. So 32.8% to be precise, with a little increase between 2020 and 2021, a 0.3% increase. So slowly things seem to improve, but really slowly. Looking closer at the different countries, the highest shares of women graduated in STEM were recorded in Romania with 42.5%, Poland, Greece, and Italy, 39%. At the lower end of the scale, we see Belgium, Spain, and Germany and Austria. So the inequalities in STEM actually go beyond studying in tertiary education to doing STEM research. So to STEM as an employment sector for researchers. Inevitably, inequalities are spread along the study employment pipeline. To have a full picture of gender inequalities in research, we really suggest you to download and go through the She Figures report that is published annually, a flagship publication of the European Commission on gender inequalities in research and innovation. Its first publication was in 2003, and it's really the best key source of comparable Europe-wide statistics on gender equality in research and innovation. So the publication traces the career trajectories of both men and women in science, mostly higher education and government research bodies, but also business enterprise is accounted for. Indeed, what we learn from the latest version of She Figures is that 4 in 10 scientists and engineers at the EU level are women, but still being underrepresented as researchers. Women are represented even less as leaders of research teams. So the report shed light on not only horizontal segregation, but also vertical segregation, and therefore the inequalities in achieving leadership positions in research, measured with several indicators, authorship, patenting, accessing to funding, sources, but also achieving the so-called grade A, which is the equivalent of full professorship at the academic level, where women still overall represent 1/3 of grade A staff, but even less depending on the disciplines. So referring to vertical segregations, or the combined effect of vertical and horizontal segregation, the She Figures report contains these two really self-explanatory graphics that represent, on one hand, to the left, the evolution of the proportion of men and women in a typical academic career, considering on the left side all disciplines. So starting from student's grade to graduation, and then the graduation at issued 8 level, that is the PhD level, then to the grades C, B, and A, that are assistant professorship, tenured professorships, and lead scientists, so full professorships in grade A, as anticipated. And what we see here is that the sister graphic highlights how women are the majority at the enrollment stage, and still at graduation, but at the level of the doctorate, the trend is inverted, and the proportion of women then start decreasing along the career ladder in scientific work, to a point where women professors, full professors, are counted for 29.5% of the entirety of grade A staff in Europe. On the other hand, the graph to the right side shows us the subfield of science and engineering, so STEM disciplines at the university level. And we see that in STEM, there's not even a scissor, because the two lines don't even meet, and the green line representing women is lower since the beginning to the very end. So 1/3 of enrolled students in STEM are women, and we get to having less than 20%, or slightly more than 20%, actually in 2022, of women as full professors in STEM disciplines. So here, that's a clear combined visualization of vertical and horizontal segregation affecting scientific careers and higher education as well. It's interesting to note that there is really a lack of data as far as intersectionality is concerned on so intersectional data in STEM education and STEM research. The European Commission is making attempts to improve the data collection in this and encouraging member states to do this, but there's still really a long way to go to have a full and complex and complete picture of how inequalities display in education and studies, not only along gender, but also along intersected inequalities dimensions. So thank you for attention, and I invite you to give a look at the reference list for further readings, and you will find all the links to the resources we built this presentation on. Thanks a lot.